Good afternoon. Um, this is the Autonomous Puzzle Solving Final Journal for ME 435. My name is Andres Catan, and the other group members were Claire Hollinger and Kyle Good. Using color extraction feature, the group is to identify the necessary block that another group needs to complete their puzzle. The group is to pick up the piece and move it to a convenient location for the second group to grab it from. And then the second task is to use the fast match function, and the group is to identify the shape of the block and correctly place it into the corresponding slot in the frame of the puzzle. The group is also responsible for rotating the block if necessary to ensure that the block fits into the slot. So for the first lab, we learned about how to do MATLAB end effector calculations. Also, we learned about the basic knowledge of how the Dobot operates and its mechanics in order to accomplish specific goals. Also, we learned how to use different jump movements in order to control the Dobot. And finally, we learned the basics of how to use the suction cup and gripper tool. So moving on, the applications of Lab 1 was that, as previously mentioned, we used the tools in order to understand the basic Dobot mechanics and how to use that in our advantage in order to properly locate and move any desired object into a specific location. Also, we learned how to change the end effector tools, which included the grippers and the suction cups in order to be able to accomplish specific tasks. And again, just the use of the suction cup enabled us to be able to move objects around.
During the second lab, we learned a lot of different skills with the DoBot. The first being the use of the conveyor belt. Next, we did the application of the IO function with the IR sensor in conjunction with the conveyor belt. We learned how to take images with the camera and how to save those images. We identified geometry with the feature template. We learned how to create a calibration code, and we also performed color extractions with the function. The skills that we applied from Lab 2 to our final project was the use of the wait function. The use of the wait function allowed us to off-put our timing when communicating with the other robot, which we learned later in Lab 3. The use of the IO function, which is also a function that we used in communicating with the other groups. We also learned how to perform match command to identify the geometry of the different letters and how to pick up those letters and place them where necessary. We did a lot of calibrating, a lot of recalibrating in order to sync the DoBot with the physical practice that we were doing. And then we learned how to pick up objects that have specific colors and place them in a different location. We also learned the value of the centroids and importance of making sure those are accurate so that our robot knew how to correctly pick up the different pieces.
In Lab 3, we used handshaking in order to combine two DoBots to accomplish one task. Handshaking is when a circuit is set up on a breadboard and the two DoBots are connected. Once one DoBot has completed a task, it sends a signal to the other DoBot to complete that DoBot's half of the task. Secondly, we also used image matching and movement and rotations in order to match blocks to fit into holes on a cardboard cutout. The rotations were calculated by using a shell module coding with input and output parameters. As stated, we used handshaking in Lab 3, and this was also used in the final project. We had to send over green colored letters to our other group and then send a signal so that they could match those letters into their puzzle piece. Now, on the receiving end of the signal, we used image matching of the letters and placed them into their designated locations. This was used through the image processing tool and using a feature template and matching the shapes of these letters into their designated areas. Using the shell module, the suction cup was able to rotate and place these letters in the correct orientation into the puzzle. In the shell module, you had to initialize variable 0 and float angle 1. In using this, you used calculations depending on the starting angle of the letter in order to communicate with the suction cup on which way and how far to rotate. Video, you see our DoBot using color recognizing to go over to a letter, and using the centroid of the blob command, it will pick up the letter and move it over to the other DoBot. After this is done, we send the signal and the other DoBot comes in, picks up the letter and places it in its block. Now our DoBot goes down and attempts to pick up another letter. It did not work as well in this video, but that was what it was attempting to do.
So in this video, we're showing a demonstration of how our DoBot was able to filter out the different colored letters. And in this specific case, we filtered out the green ones. And this was done via the color extraction feature, and also by being able to calculate the centroid location of each letter. The DoBot was able to pick them up and successfully place them in a required location.
For the second task, we had to identify the different letters and place them into the frame correctly. For this, we used code, specifically the fastmask function. The fastmask function allowed us to create feature templates for each letter. The first fastmask function we used identified the color letter, and the robot would pick it up. The second fastmask function identified the letter in the frame, and the two worked together to correctly place the letters into the frame. In addition to that, we also used the shell function, which was previously explained, and this allowed us to correctly rotate the objects so that they could align with the letters in the frame.
In summary, the group was able to successfully complete tasks 1 and 2 on their own. However, the group did struggle when attempting to complete the task with another group. These issues came from the other group's progress in the project as well as the overall time constraint. In conclusion, the group gained a strong understanding of the DoBot program and successfully overcame challenges on their own.